Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the introduction to differentiation. This is part 1. Make sure to subscribe so that you don't miss out on any of our future uploads. Recall, we can draw and estimate the gradient of a function f of x at a point x is equals to a. Of course, we would need to construct a tangent and then find 2 points. Then we find the gradient as the change in y over change in x. And using what we have in the graph on the left, we would have the gradient given by b2 minus b1 over a2 minus a1. However, the above method is only an approximation, and we can actually calculate the exact gradient by differentiation. So, differentiation is the process of deriving what we call the gradient function, which is also meant to be like a gradient formula for a function to find gradient at the point x is equal to a or any other point of x. Let the gradient m be the change in y over change in x, given as delta y over delta x. The notation of differentiation. 1. So if we have y is equal to f of x, then the derivative can be expressed as dy dx or d dx of f of x. And we call this the derivative of y with respect to x, dd in short. Now 2, y prime is equal to f prime of x. And note, where the apostrophe is known as the prime, or we just denote it and call it prime. Let's look at the rules of differentiation. 1. Power functions. If we have y is equal to x to the n, where n is an element of real numbers and not equal to 0, then we have our dy dx given in the form x to the n. We multiply with the power n and subtract 1 from the power so that we get dy dx as being equal to nx to the power n minus 1. Let's look at the first example. Find the derivative of y is equal to x to the 4 and find the gradient of the curve at the point 1, 1. The solution. Y is equal to x to the 4. Then dy dx, we drop the power, which is 4, multiply it with x to the 4 and subtract the power by 1 so that we have that. And simplifying that, dy dx is equal to 4x cubed. Now, moving on to the second part of the question, the gradient of the curve at 1, 1, then it means that the y prime of x is 4x cubed. Then where we have x, we just substitute with the 1 because x coordinate is 1. So we have that so that our gradient at the point 1, 1 is equal to 4. Example 2. Differentiate with respect to x. The cube root of x squared. The solution. Now recall from the laws of indices. And I encourage you to check out our indices videos so that you see what we were doing. Now, so that can actually be expressed as x to the power 2 over 3. Then it means that the dy dx, or the d dx in this case, of x to the 2 over 3 will be, we drop the power 2 over 3 times x to the 2 over 3 minus 1. Simplifying that, we would get that. And of course, from the laws of indices, that can be expressed as that. And finally, we have our answer as that. Let's look at example 3. Differentiate with respect to x. X to the power 5 divided by x squared. The solution. Recall from our laws of indices video, which I encourage you to check out, we can actually simplify this to x to the power 5 minus 2 so that we get x cubed. Now, applying the derivative or the differentiation of x cubed, we are going to have 3 times x to the 3 minus 1. We dropped the power 3 and we subtracted 1 from the power. Simplifying that, we are going to get 3x squared as our answer. Let's look at the second rule. Scalar multiple. If y is equal to a x to the n, where a is a constant, then the dy dx will be given by. We separate the a and find the derivative of what's left. That's the x term, x to the n. Then, of course, we would differentiate in the normal way. So we still have our a times the n, which is the power dropped. And of course, to the new power, we subtract 1 so that we have dy dx as an x to the n minus 1. Right, let's look at an example. So find the value of the gradient of the curve at the given point. So we have y is equals to 2 root x at 4.4. So the point here is 4. Right, solution. We are going to simplify this to 2x to the power half from the laws of indices. Then finding the y prime or the derivative, we would have it as this. We shift the 2 to the far left. So the 2 is still multiplying what we're going to differentiate. So we get the d dx of x to the power half separated. Now with that, we are going to get our y prime of x being a 2 times half the power that we brought down times x to the half minus 1. Remember how we differentiate? And simplifying further, we are going to get the y prime being x to the power minus half. Now that we have the gradient function is that, we need to find the gradient at the point 4. So x coordinate is 4 according to this point that we have. So y prime of 4 is simply substituting 4 in place of x in the gradient function so that we have that. And of course, from the laws of indices, we would have that so that our answer comes out as 1/2. Therefore, the gradient of the curve at 4 is 1/2. Let's look at example 5. Find the derivative of f of x. So f of x is equals to 2x root x all over 3x cubed. Now the solution. From the laws of indices, we can actually simplify this further to that. And simplifying it further, we can actually get to that particular point. Great. So now we move on to find the derivative. So f prime of x will be given by 2/3 d dx, and we differentiate the x term. So now we have that constant 2/3 times the power, which is negative 3/2 times x to the power minus 3/2 minus 1. Simplifying that further, we are going to get minus x to the power minus 5/2, simplifying it to that final answer. Let's look at the constant rule. If a is a constant and a is an element of real numbers and y is equals to a, then the derivative of y is equals to 0. Now, so every constant, if it doesn't have any x term, that would give us a 0. Let's look at this quick proof. So the constant, if we have y is equals to a, that can actually be expressed as a times x to the 0, and y prime then would be a times 0 times x to the 0 minus 1, which would just simplify to 0. Awesome. Let's look at example 6. Differentiate y is equals to 5. The solution. So it means that y prime is equals to 0. Let's look at then the addition and subtraction rule. If f of x and g of x are functions, then the d of x of f of x plus or minus g of x, that can actually be simplified or differentiated separately. So the x terms can be separated and differentiated separately, preserving the signs. Let's look at a quick example. Example 7. Find the gradient of the curve. So we have that particular curve at the point 0, 3. The solution. So y of x is equal to x squared minus 2x plus 3. So the derivative, we find the derivative of the x squared first, which is dropping the 2 and subtracting 1 from the power. Then we also move on to the minus 2x. We drop the power, which was 1. We subtract 1 to the power, and we know the constant would be 0 when differentiated. Then y prime of x is going to be 2x minus 2. Now that we have the gradient function, we now want to find the gradient at that particular point, 0, 3. So y prime at the point 0, since the x coordinate is 0, we substitute 4x so that we have 2, 0 minus 2. Then simplifying that further, we're going to get the answer is minus 2. Therefore, the gradient of the curve at the point 0, 3 is minus 2. Let's look at example 8. So we are meant to find the gradient of the curve, which is a cubic curve, at the point 1, 5. And we're given actually that the gradient is a minus 5. Find the value of A and the value of B. So the gradient is already given, but we're meant to find the values of A and the values of B from the information given. Right, so we have our y of x is that, so meaning that our y prime of x would be given by 3x squared plus 2ax plus b plus 0. I'm sure we see how we get to that using what we have been doing. So now, meaning that we can actually set that gradient function y prime of x to be equal to minus 5 at the point 1, 5. So where we have x, we substitute with the x coordinate, which is 1, so that we have that. So simplifying that, we are going to get that so that we have the first equation as 2a plus b is equal to minus 8. Let's label this equation 1. Now, we also know that y at the point 1 on x would give us a 5 on the y coordinate. So we substitute for 1 on the y, not the gradient function or y prime. This is in the y curve. So where we have x, we substitute with 1 and equate that to 5. So simplifying further, we are going to have a plus b is equal to minus 3. Let's label this equation 2. Right, so we have two equations, and from equation 1, we make b the subject of the formula so that we have b as minus 8 minus 2a. Let's label this equation 3. Now we substitute for b into equation 2 so that we get a minus 8 minus 2a is equal to minus 3, implying that a is equal to minus 5. Now substituting for a into equation 3, b will be then given to be 2 when simplified, implying that our solutions are a is equal to minus 5 and b is equal to 2. Let's look at the last example for the day. So if we have that cubic curve and we're asked to find the range of the values of x for which dy dx is greater or equal to 0. The solution. So y is given to be that, implying that the gradient function y prime will be given by that. So we drop the powers and we subtract the power by 1 so that we get to that. Simplifying further, we are going to get our dy dx as 12x squared plus 6x minus 6 is greater or equal to 0. The next thing is to solve this inequality, but remember from the quadratic inequality videos, and I encourage you to check it out because we are not going to cover this one in great detail in this video. So now we set the inequality to be equal to, so we have 12x squared plus 6x minus 6 is equal to 0. Now dividing throughout by 6 and also factorizing, we are going to have 2x squared plus x minus 1 is equal to 0. Factorizing, we have 2x minus 1 times x plus 1 is equal to 0. And I encourage you to check out the quadratic factorization video that we covered. Now moving on, we are going to set this to 0. So 2x minus 1 is equal to 0, x plus 1 is equal to 0, implying that we have x is equal to a half, or x is equal to minus 1. And also, since the coefficient of the quadratic is 12 greater than 0, this means that the curve has got a minimum vertex. And I encourage you to check out these videos we covered on quadratics. And we're moving on. We are going to have a sketch of that nature, and we are interested in values that are positive on the graph in terms of the y, implying that our solution then would be x is less than or equal to -1, or x is greater or equal to a half. If you have made it thus far, I say congratulations to you. I'll leave you with the following task. So make sure that you do this task and let me know of any problems that you might have encountered. Remember, your feedback, comments, and suggestions are always welcome here. Let me know of any future topics that you would want us to cover. Thank you so much for watching Numbers Simplified. Make sure to like, share, and subscribe so that you don't miss out on any of our future uploads. God loves you.